In the previous video, we briefly saw some important points of the current landscape of artificial intelligence. But when did all of this start? In the 1940s and early 1960s, complex machines were used. The Bomber device was used to decrypt German messages from the Enigma machine during World War II. The Unimate machine was the first industrial robot which worked on a General Motors assembly line. It is the distant ancestor of the machines used today in the industry. In 1950, mathematician and cryptographer Alan Turing proposed a test to evaluate the intelligence of machines, which is known as the Turing Test. A machine that can make a person unsure if they are talking to a machine or a person would have passed this test, Alan Turing declared. But it wasn't until 1956 that computer scientist John McCarthy coined the term artificial intelligence and organised the Dartmouth Conference, considered the beginning of the field of AI. In the 1960s and early 1970s, 1 year after the first human walked on the moon, the first AI projects were developed, including the chatbot Eliza, one of the first programs that could hold a conversation with humans. Another interesting project was the robot Shaky, one of the first computer-controlled mobile robots. It was during these years when Rosenblatt invented the Perceptron, the basic neuron used in AI models. The Perceptron is an algorithm for distinguishing between two classes. It is also capable of adjusting itself during its training. Understanding how it works is a key point for the development of new AI techniques. A perceptron has multiple inputs and a single output. The input values are modified by weights, which are assigned randomly and then automatically adjusted. These modified values are summed and compared to a predefined threshold value, resulting in an output of either 1 or 0. To understand how the perceptron works, we can use the AND logic gate, which is an essential building block of modern electric systems. This gate returns a value of 0 when any of the inputs is different to 1. If both inputs have a value of 1, the gate returns the same value. To train our perceptron, we will start with randomly assigned weights, let's say 0.9. In the inputs, we have the values 0 and 0, which, when multiplied by the weight values, still equal 0. Next they are summed, resulting in 0. This value enters the step function, where it is determined whether it is greater or less than 0.5. As it is smaller, the correct output of 0 is obtained. Now the input values are not equal. This time, when the value 1 is multiplied by the weight, we obtain 0.9. When the values are summed, the result is greater than 0.5, so the final output is 1, resulting in an incorrect outcome. When the result is incorrect, the perceptron modifies the weight values. The error made is the actual value minus the predicted value, in this case 0 minus 1, resulting in a negative value of 1. The weight value is adjusted, taking into account a parameter called learning rate, which allows us to adjust how quickly the algorithm learns. For this example, let's set the learning rate to 0.5. Therefore, the adjusted weight value would be the previous value plus the product of the learning rate and the error, obtaining a new weight of 0.4. Once the weights have been adjusted, if we repeat the calculations, we can see that the expected results are obtained this time. It was only necessary to update the weights once, but with different initial values of learning rate or weights, this process could have been much longer. Thanks to the perceptron, nowadays we have very complex models capable of detecting diseases or making impressive drawings in a matter of seconds. A set of many neurons forms a neural layer, and to achieve complex models, more than one of these layers are used. Around 1960, we saw the first multi-layer networks, which led to the invention of new methods for adjusting the weights of the corrections between all the neurons in a neural network. In 1970, the technique of backpropagation began to be discussed, which increases accuracy by propagating errors backwards through the network. It is used to train deep neural networks for complex tasks such as image and speech recognition. However, those are not the only techniques to consider that appeared in this decade. The k-nearest neighbour algorithm was also invented in that decade and is a method that allows us to classify or make predictions about the grouping of an individual data point. It is used in image classification, social network analysis, credit card fraud detection, among others. Despite its simplicity, it is a very useful and widely used tool in the field of machine learning. To classify the mysterious silhouette into one of the groups, we will take into account the K parameter, which tells us how many neighbours we have to observe to make a decision. If we set K equal to 5, we can see there are 3 capybaras and only 1 dog and 1 cat. Therefore, we decide that the mysterious silhouette is a capybara. Choosing the K parameter is important and not always easy. The process of choosing is called parameter tuning. We have seen that the field of artificial intelligence is advancing very quickly. But it hasn't always been like this. Why has it only become such a viral topic recently? In the next video, we will see that not everything has always gone so well.